Okay, let's look at some limit statements here given a piecewise function graph that I've already created for you. So notice this point right here, this is an open circle and this is a closed circle. This open circle is infinitesimally small, meaning infinitely small, if you will, which is somewhat of an oxymoron. So this point is really, really tiny. It's just the easiest way I could do it using is graphing software called Geometry Sketchpad is it's to make it a pretty big hole. But it's really, really tiny. So it's smaller than this red dot. And this one, so this for this is a closed circle. Again, here's closed and this is an open circle. Again, this hole is really small. Here's a really small hole and here's the corresponding point, making it so that it's not continuous here because there's a hole. Excuse me, there's a hole here and there's a point way down here. Okay, so this is just some random piecewise function that I created. We're going to look at some limit statements here, where then there's a negative exponent. That means you're looking at the limit from the left-hand side, and when you're looking at the limit from the right-hand side, it's a positive exponent. And if you're looking at the limit from the left and the right at the same time, there's no exponent written there at all. So we're going to look at a couple different limits, some 0, and then some 2, and then some other ones down at the bottom. On the next page, excuse me. So let's look at our first limit. The limit as x approaches 0 from the left-hand side, so that's a negative right there. So therefore, left-hand side, my function value is going up to 2 because, again, how small is this hole that's here? Really, really tiny, smaller than the red dot that I just created there. So the limit doesn't really care that there's a hole there. Where is the function going towards as x approaches 0 from the left-hand side? 2. So the limit is equal to 2. The right-hand limit as x approaches 0, so where is my function value going from the right-hand side? As I approach 0, it's going towards 1, so my limit is equal to 1. As x approaches 0, that means I forgot to write down 1 there. As x approaches 0, that means you consider both the left and right-hand side. The left and right-hand side must agree in order for this limit to exist. Since the left-hand limit is going to 2 and the right-hand limit is going to 1, the limit does not exist. So you actually need to write that answer down. So you can write down DNE, which represents does not exist, since, I got too many i's there. Let's erase the whole thing. Since, I don't have an I at all, since the left-hand limit, LHL, equals 2, which is not equal to 1, which is equal to the right-hand limit, so these two limits are not the same. There you go, that's it. The limit doesn't exist since the left and right hand limits do not agree. So let's look at a different limit. Let's look at the as x approaches 2. Here's 2 right here. So the left hand limit would be on this side. My function value is going towards 1, so my left hand limit is equal to 1. My right hand limit as x approaches 2. My function value is going way up here to 3. So again, this hole is really small. So my function value is going towards 3. So that's 3. And finally, as x approaches 2, does the limit exist? No, because the left-hand limit is 1, the right-hand limit is 3. Therefore, the limit doesn't exist. So we briefly discuss the limit does not exist since the left-hand limit equals 1, which is not equal to 3, which is equal to the right-hand limit. So let's scroll down to our next set of problems. Same graph, just different questions. So here we have the same graph again. Here we're looking at the limit as x approaches 3, and then down here we're looking at negative 2. So as x approaches 3 from the right-hand side, so here's 3 right here. So from the right-hand side, I changed the order in these set of problems. I first consider the right-hand side. The right-hand side, my limit is going towards 2. Now note the point down here, the function value at 3 is equal to 1, but the limit doesn't care about that. The limit is where's the function going towards as x approaches 3 from the right-hand side. It's going towards this function value right here. So my limit statement is 2. Likewise, my left-hand limit, my function value is going towards 2 from the left-hand side. So therefore, this is also 2. And as x approaches 3, since the left and right hand limits, these two limits are the same. This limit exists and it's 2. Again, this point here has nothing to do with limits. Limits don't really care about the actual function value, just provided that the function is going towards the same spot from the left and right hand side. Here's the endpoint limit. We're looking at negative 2, which is this on our coordinate plane right here. We're looking at the right hand limit as x approaches negative 2, so that would be 0. And then this question is kind of dumb. It asks, as x approaches negative 2 from the left-hand side, well, traditionally you don't really discuss limits where the function is not defined. The function is not defined for x values less than negative 2, so the limit doesn't even exist because the function doesn't exist. So this question is not very interesting. And does the limit exist as the limit exists as x approaches -2? No, because the left-hand limit, there's no function value, so it doesn't exist. This is kind of an annoying question. I should have deleted it, but I was too lazy to do that. Okay, so now this one we're going to do some true-false essentially. If it's false, we just want to briefly discuss what the answer would be. Here's a different graph, so therefore this hole right here again is really small, and here's this dot right here is the same size as that hole. Here's another hole with the corresponding dot being up there. So therefore, obviously, the limit doesn't exist here. The limit does exist here. That's about it. So we're just going to answer some true-false questions given this graph. So as x approaches -1 from the right-hand side, so -1 is over here, right-hand side, my limit is equal to 1. That's a big true. The limit as x approaches 2 doesn't exist. So here is 2. The limit does exist because the left-hand limit is going towards 1. The right-hand limit is also going to 1. So therefore, this statement is false. The limit equals 1. The limit as x approaches 2 is 2. That is false. The function value is 2. That's true, yes. But the limit is, where is the function going as x approaches 2 from the left and right hand side? It is going to 1 in both directions, so therefore this is not 2, it's actually 1. X approaches 1 from the left hand side is equal to 2, so x approaches 1 from the left hand side, so that would be on this side. The limit value is 2, so therefore this is true. Here's a couple more true-false questions with the same graph. So here is, as x approaches 1 from the right-hand side, my limit value was 1. So right-hand side, my limit value is 1. That's true. The limit as x approaches 1 does not exist. Well, my left-hand limit is 2. My right-hand limit is 1. Therefore, the limit doesn't exist. So this is also true. And does the left-hand limit at 0 equal the right-hand limit at 0? That's true. It's equal to 0, so that is true. So we really only wanted to do some justification if you say false. Here's our last question. Does the limit exist for every x, which is in the interval -1 to 1? So from -1, not including -1, to +1, not including +1, does all the limit values, do they all exist in between these two values right here? Yeah, there's a limit all around here and here. There's obviously not a limit at +1, but we don't care about that because we're on the open interval. So therefore, this statement is true. So that takes care of that one. See you at the next one.